The biochemical oxygen demand is an empiric laboratory assay which indirectly measures the amount of organic matter contained in a water sample. This assay is the most widely used method for the assessment of water quality. The equation on the screen describes the biochemical process behind the BOD assay. BOD is, in fact, a measure of the amount of oxygen consumed by heterotrophic bacteria for the oxidation of organic matter. Hence, BOD is expressed in milligrams of oxygen per liter. And the higher the amount of organic matter in water, the higher the BOD value. Although there exist various methods for BOD measurement, the principle is the same for all of them. A volume of water sample is put in a recipient where the changes in the oxygen content are measured before and after incubation at 20 degrees for a certain time. If the sample is expected to have a low content of microorganisms, an inoculum should be added. Moreover, an extra nutrient solution may be added to ensure that the growth of microorganisms is not limited. BOD values increase over time as organic matter is progressively biodegraded. However, after 5 days, the majority of the organic matter contained in the sample has already been degraded. For that reason, BOD 5, which is measured after 5 days of incubation, is the most widely used method. On the other hand, if the aim is to measure the total content of biodegradable organic matter, BOD 21 is measured after 21 days of incubation. The oxidation of other compounds present in the water sample can also contribute to the consumption of oxygen. In particular, nitrification could interfere in the measurement of BOD, leading to an overestimation of its value. To prevent this, the use of an inhibitor is required. So now that we already know the theory, let's have a look at how we actually measure BOD 5 in the lab. It consists of placing the sample in a recipient sealed with a manometer and in constant agitation in dark conditions. The manometer measures the decline of pressure inside the recipient caused by oxygen consumption. With the measured decline of pressure, the mass of oxygen that has been consumed is calculated using the ideal gas law. Sodium hydroxide is added to absorb the carbon dioxide produced in the process, which might interfere in the pressure measurement. First off, we introduce a magnet inside the bottles so that when they are placed on the magnetized tray, they remain constantly agitated. Now, we need to determine the volume of sample which will be introduced in the recipients. For that purpose, we previously need to make an estimation of the expected BOD range of the sample. With that information, we go to the table provided by the device manufacturer, which establishes the specific volume of sample to be put in the recipient for each BOD range. Now, let's imagine that we expect the BOD of our sample to be somewhere below 200 milligrams of oxygen per liter. In that case, we can see that the volume to incorporate to the recipient is 250 milliliters. To measure the exact volume, it is necessary to use well-suited volume measuring tools. Once the volume is measured, we must introduce it into the recipients. To ensure that we will always fall within a valid range, it is recommended that 3 different volumes are used for each sample. At this point, we will add the nitrification inhibitor. Now, it is time to put the sodium hydroxide into the plastic enclosure located within the manometric cap. Next, we can proceed to firmly close the bottles to guarantee an airtight environment inside. After that, we make sure all manometric caps are reset to start measuring from afresh. Once that's done, we introduce all recipients containing our samples in the magnetized tray, which is already located inside the incubator at 20 degrees Celsius in dark conditions. After 5 days in the incubator, it is time to take the measurements of the manometric caps. If the value is out of range, no value will be displayed. Once the values of the manometric caps have been noted down, one more step is needed to get the final BOD5 value. To that end, we will use the following equation, where the term factor appearing in the formula corresponds to the figure obtained from the standard table for our specific sample volume. In our case, we have used a sample volume of 250 milliliters, since we estimated that our BOD value would not exceed 200 milligrams of oxygen per liter. Then, as you can see in the table, the value of the factor to be used is 5. Now, we proceed to multiply this factor by the value of the manometric cap display, which is 25. With that, we obtain a final BOD5 value of 125 milligrams of oxygen per liter. With that, we reach the end of this first video tutorial. Thank you for your attention and hope to see you in the next video of this series.